Right now we're going to show how to completely solve a triangle using the law of sines when we know any two angles of that triangle and then one side of the triangle. Now let's recall that the law of sines can be written as A over sine of A equals B over sine of B equals C over sine of C. Essentially, the ratio of any of the sides to the sine of the angle opposite of that side is going to be a consistent factor. So let's say we're given a triangle and we're given the measure of angle A and the measure of angle B. In this case, we're going to say A is 35 degrees, B is 65 degrees, and we are told that side A is 10 units long. And the question that we're given is solve this triangle. So that means that we have to find what angle C is and what the lengths of sides B and C are. And no matter which angles we're given and which sides relative to we're given. So if we had been given C instead of A here, we're going to follow the same method each time. Right? Our first step is going to be to find out whatever the measure of the third angle is here. And we're going to use the triangle angle sum theorem that you learned back in geometry to calculate what the final angle is going to be. So let's recall that all three of these angles have to add up to 180. So if we take our 35 and we take our 65, we add them together, that's going to get us up to 100. Subtract that from 180, and that's going to result in C in this case being 80 degrees. Okay. And now that I have all three of my angles, I can set up a proportion here. So I can use A and sine of A, as well as sine of B and sine of C, to solve for B and C. So our proportion here is going to be 10 over sine of 35 degrees. It's going to be equal to B over sine of 65 degrees equals C over sine of 80 degrees. And from that, I can cut this up into two equations that allow me to solve for B and C. So in the first case, my B equation is going to be B is going to be equal to the 10 and then sine of 65. That's what I'm going to bring over to the other side here in this equation. And that's all going to be divided by sine of 35 degrees. Okay? And then we can plug this into the calculator. And up here I have an example of a TI-84 that you might be using. We're going to plug this in by first parentheses, then 10 times the sine function of 65, close that parentheses, close out my other parentheses, divide that all by the sine of 35, closing out my parentheses. And I'm going to hit enter. Oh, and this came up with a negative number. So what did I do wrong here? Because B and C have to be positive numbers. They're sides of a triangle. What I did wrong here was I didn't make sure that my calculator was in degrees instead of radians. So I want to make sure. I'm going to go into my mode, go down, there it is, it's in radians, not in degrees. I'm going to hit enter for my degrees, and then get back into my main calculator, and I'm going to plug this in one more time. So it will be open parentheses, 10 times sine of 65 divided by the sine of 35. Hit enter, and 15.8009 is what I'm looking for. So B is going to be approximately 15.801 if I go to my thousandths place. Let me do this again for C. So again, I'm going to set up that same equation. This time C is going to be equal to 10 sine of 80 degrees divided by sine of 35 degrees. Back over to my calculator. 10 sine of 80 divided by sine of 35. Now it's very important to get these parentheses up top here, so you're telling the calculator the order you wanted to do the operations. Hitting enter, 17.165. We're going to approximate that to 17.170. That's going to the thousandths place. So my final answer on this question would be to plug in my B and C values. And up top here, I have now solved this entire triangle. And that's how I do it. Every single time, I'm going to solve for whatever my third angle is first, set up my law of sines proportion, and then solve for B and C. And it's going to be that same equation each and every time.